Okay, we're going to consider the solid obtained by rotating the region bounded by y squared is 2x and y equals x about the y-axis. And we're going to find the volume of the solid. Let's start with algebra to get where these two curves intersect. We're going to set them equal to each other. Easiest way to do that is by solving for x in both. So on the one hand, x is y squared over 2. On the other hand, x is y. So these two need to be equal to each other. Y squared over 2 is equal to y, or that y squared is 2y. So y squared minus 2y is 0. And we'll factor out the y. And we get that y is 0 and y is 2. Okay, great. The first curve is a parabola on its side, opening to the positive x. And the second is our line y equals x. So and we have it at y equals 2 and at y equals 0. So our region is this region between these curves. I'm going to rotate this around the y-axis. Okay. Because there's a gap between the region and the axis of rotation, we have our choice between washer and shelves. Can't tell you which one is any better than the other, so let's try washer. Where we go and put a typical rectangle that is perpendicular to the axis of rotation, and then we have to find the inside radius, call it little r, and the outside radius, call it capital R. So when it's attached to the x-axis like that, the distances are x distances, so we have x for the parabola is little r, and x for the line is big R. Outside radius and inside radius. So the inside radius is y squared over 2, and the outside radius is just y. We're doing this in terms of y because we have a typical rectangle that is horizontal, so this means the integral is dy. Okay, so we set up washers, which is that the volume is equal to pi times the integral from a to b, in this case 0 to 2, the outside radius squared, sorry about that, minus the inside radius squared. And so our volume is pi times the integral from 0 to 2 y squared minus 1/4 of y to the 4th. And just to finish this off, we have y cubed over 3 minus y fifth over 20, and that goes from 0 to 2 with the pi on the outside. So we're going to have 8/3 minus 32/20. and that's multiplied by pi. We could reduce the 32 over 20 to be 16 over 10. So we have 8/3 minus 8 over 5. We're reducing all the way down. And so we'll have 40 minus 24 all over 15. So the answer to the question is 16 pi over 15, whatever units we have cubed. Very good.